Hello students, today we are going to understand the rate of cooling. I will explain how the numericals based on rate of cooling is done. I have an example for that, numerical example. And okay, so let me get started. So I'll use a pointer pen. Okay. So the question is, you have a solid cube, okay, and a solid sphere. I'm sorry, question, is it visible? Hang on. Okay. So a solid cube and a solid sphere of same material have equal surface area. I will read out the question so that even if you cannot see because of this video thing, hang on. Ah, you can see. Okay, fine. A solid cube and a solid sphere of same material have equal surface area. Both are at the same temperature, 150 degrees Celsius. Then one of these options you have to choose. This question was asked by one of my students through the Telegram channel. You can join as well. So let me start. So tell me one thing. If you have a solid cube and you have a solid sphere, the condition is surface area is same. So, and both are at same temperature. So 150 degrees Celsius per, they will have some energy, right? At 150 degrees Celsius, they will have some thermal energy. Of course, I'm talking about thermal energy. So what that thermal energy be? Can I just, okay, so next slide, I'll be taking next slide. Okay, okay. Somehow I think this is important. Okay, fine. So for cube, okay, for cube, what is that energy? Let me call it Q. Okay, Q dot that, or just Q. You can just take Q. Okay, so M C, C is the specific heat of that material, right? Into delta T. What that delta T would be? Some temperature T, instantaneous temperature minus surrounding temperature, right? Upon some time T. Okay, or you can just write it in another form. Why instantaneous? Because at a particular time, this would be the energy stored in it. Okay. So MC, just write dt by dt in differential term. Okay. This makes more sense. Okay. Now, how the cooling will occur? By the way, this is not just for cube. I'm going to try to derive the expression for rate of cooling. Then I will स्पेसिफाई कि क्यूब के लिए क्या सीन होगा और स्क्वायर के लिए क्या सीन होगा. ठीक है. सो डीसी बाय, ओके, हाउ विल दैट बॉडी विल कूल, राइट? ड्यू टू द क्वेश्चन में कन्वेक्शन दिया है, विंड फ्लो हो रही है, नो देयर इज नो एयर, तो कन्वेक्शन का we will rule out the convection. Convection will not be present, right? There is no motion. Okay, motion of fluid over the body. So convection, that's how we define, right? For a basic definition, you must understand what is convection, what is conduction, right? So what is other mode of heat transfer? See, one you are familiar with, conduction. Other is convection. So convection तभी होता है when there is a flow of fluid over a body, या फिर जो body है वही fluid है and there is a motion. Okay, and other mode is radiation. Okay, so of course conduction तो throughout the tube के अंदर होगा, right? और from the surface cooling होगा, right? So from the surface, what is the mode of heat transfer? Convection we have ruled out because question में भी ऐसा कुछ नहीं दिया है कि there is a wind flowing over it या फिर ऐसा कुछ. Okay, so radiation will be present. It doesn't need a medium. It doesn't need anything. Radiation will always be present. Okay, it doesn't even need a temperature, right? If even if it is lesser than surrounding temperature, still there would be radiation, right? Of course, in the other direction or direction of heat transfer will always matter. Okay. But here, of course, we are going to assume that surrounding temperature is lesser than the body temperature because cube and sphere both are at 150 degrees Celsius. Okay, fine. So how the radiation heat transfer takes place? This Q dot is Stephens-Boltzmann law, right? Sigma, Stephens constant, Stephen-Boltzmann constant, sigma, epsilon is emissivity, right? And into area into T instantaneous to the power 4 minus T surrounding to the power 4. Isn't it? Okay. This comes in watt, right? So unit हमेशा unit से भी आप समझ सकते हो, in these exams कि this is watt and this mc delta t is not watt. It's just joule. So mc delta t upon dt you have to do it. So both should be equal. Whatever energy you have, it will try to dissipate. It will try to go to the atmosphere surrounding. Okay. So यहाँ से क्या आ गया? mc delta t by dt is equal to sigma epsilon a t to the power 4 minus t naught to the power 4. What is dt by dt? D capital T is the temperature, small t is the time. What is it? It is rate of cooling, right? A t to the power 4 minus t naught to the power 4 upon m into c. Tell me one thing. Both cube and sphere, let's just assume cube and sphere, they have same material. Same material, so C will be same. They have same initial temperature. Same, they are put in the same surrounding. T naught same होगा, capital T same होगा. Stephen Boltzmann constant, it's a constant. It doesn't depend on anything. I mean, yeah, it doesn't depend on anything. It's a universal constant, right? 5 into 6, 7 into 10 power minus 8, 5, 6, 7, 8, right? That's how you remember. Emissivity depends on the material, and both material are same. Both material are same. So what is this rate of cooling? dt by dt is rate of cooling. By the way, this rate of cooling, there would be a negative sign because you don't, but here you do not need. Why negative sign? Because this T will be reducing, dt by dt will be reducing. Okay. Now, dt by dt. Now, this dt by dt will depend on A and mass. Okay. So let's just move on to the next slide. What we derive, dt by dt is proportional to area upon mass. Again, what can you write mass? Mass, you can write density into volume. Density remains same because both material are same. So you can just go another step. अगले step में you can write A by B. Now, some informations are given in the question. Okay. For example, cube and sphere, they have surface area to be same. If surface area is same, try to find the relation between the side length of the cube and diameter of the sphere. What is the surface area of the cube? Six faces are there, six a square. Let's say a is the side आप assume कर लो a और इसका diameter आप assume कर लो d. ठीक है. This is equal to what? Pi by 4 d square, right? यहाँ से area, sorry, area नहीं, side of the cube will be equal to pi upon 6 4 the 24 to the power what? Half into d. By the way, if area is same, given same, so एक step और चले जाओ, dt by dt is inversely proportional to volume of the body. Okay. Now you have to find volume. So volume of cube कितना हो जाएगा? Tell me. A cube, इसको क्यूब करोगे तो क्या आ जाएगा? पाई बाई 24 टू द पावर 3/2 d cube. Now, what is the volume of sphere? Hey, let me check if it is recording. Yeah, it is recording. Sorry. I get scared because after making the video and it turns out that it is not recording, I'm screwed big time. Okay. It takes a lot of effort, right? If you can understand that. Fine. Volume of sphere क्या हो जाएगा? Pi by 6 d cube, right? 4 by 3 pi r cube, and then you convert r into d, something like this. Okay. अरे यार, ऐसे होगा ना। आर क्यूब, आर को आप डी बाई टू होल क्यूब लिख सकते हो। दिस इज एट, एंड देन फोर टू जा एट, फाइव थ्री टू जा सिक्स, फाइव बाई सिक्स डी क्यूब। Now tell me one thing, which, so d cube is same. We are trying to compare the volume of both the body, cube and sphere. Which factor is more? This is pi by six. Pi by six को हम approximately one by two बोल सकते हैं, right? Pi is 3.14, three two जा six. What is pi by 24? Three अगर इसको मानेंगे तो three eight जा one by eight to the power three by two, ऐसा मान सकते हैं। One by eight is much smaller than one by टू, एंड वन बाई टू के वन बाई एट में पावर भी है थ्री बाई टू। ठीक है। सो व्हेन यू स्क्वायर और क्यूब नंबर स्मॉलर देन वन, इट रिड्यूसेस 0.001। ये सब आइडियाज माइंड में ऐसे रखा करो, so that you can get to the answer very quickly. Okay, I'm not getting to the answer very quickly because I'm trying to explain. Okay, this video can be made in 1 or 2 minutes. I'm trying to explain. Fine. So which volume is smaller? Cube का volume is less than volume of sphere. ठीक है। यहाँ से ये चीज याद भी कर सकते हो। यहाँ पे कोई भी फिजिक्स यूज नहीं हुई है, केवल मैथ यूज हुआ है। अगर आपके पास एक क्यूब है और एक स्फीयर है, दोनों का सरफेस एरिया सेम है, तो क्यूब का वॉल्यूम कम होगा स्फीयर के वॉल्यूम के कंपैरिजन में। ठीक है, तो ये चीज, ये फैक्ट है। ठीक है, देयर इज नो फिजिक्स हियर। आई मीन, फिजिक्स इज ऑल्सो फैक्ट, आई एम सेइंग कि इट्स ऑल मैथ, यू कैन यूज दिस फैक्ट एनीवेयर थ्रू आउट योर एग्जाम। ओके, or you can come to the conclusion in other questions, similar questions. Okay, dt by, so rate of cooling किसका फास्टर होगा? जिसका वॉल्यूम कम होगा। तो क्यूब का, लेट मी से आर, ये रेट ऑफ कूलिंग आर सी, ये आर सी वुड बी लार्जर फॉर, let me say r only. So rc would be for cube and r would be for sphere. Okay, so rate of cooling for cube would be larger. Okay. Now tell me what is the option. So which one will cool faster? Cube, right? So I think second option is true. Uh, okay, I will, yeah. Which option is here? Sphere will cool down faster. No. Cube will cool down faster than sphere, of course. This one. Okay. So which option is correct? One. Okay. Do share the video. Do subscribe to the channel. You can comment if you do not understand the question. And of course, keep sharing the video, subscribe the channel, and keep asking the question by joining the Telegram channel. Link for the Telegram channel का लिंक जो है वो आपको डिस्क्रिप्शन में मिल जाएगा, मेरे अबाउट में, चैनल के अबाउट में मिल जाएगा। सो यू कैन जस्ट ज्वाइन एंड कीप आस्किंग द क्वेश्चन। ओके, थैंक यू, बाय।